In this video we focus on how to derive Newton's algorithm. Newton's algorithm is an efficient way to solve, to find roots of equations by doing particular kinds of approximations. So you have that xk plus 1, the next approximation of the root is equal to the previous one minus the quotient of the function evaluated at xk over the derivative of the function evaluated at xk. So we take the equation of the tangent line at xk, f of xk. For y is equal to 0, we have minus f of xk equals f prime of xk times x minus xk. We divide by the derivative f prime of xk, taking that f prime of xk is non-zero, and we have that x minus xk equals minus f of xk divided by f prime of xk, and from here we have x equals xk minus f of xk over f prime of xk, and this can be written as xk plus 1, so the next root should be the previous one, the previous approximation, minus this quotient. And the stopping criterion to stop the iterative process is the following. The previous approximation and the next approximation, if the difference of these two approximations is less than epsilon, where epsilon should be of 10 to the power of minus 4, so if the difference is really small, then you stop the iterations. This is stopping criterion, and epsilon is called usually in the numerical methods tolerance. This is the Newton's algorithm. And this is the stopping criterion to stop the iterations. So you compute each time approximations, and at certain point the difference between the two approximations should be a very small number.